Okay, so this is an introductory lab, and it's all about the relative reactivity of metals, so how reactive certain metals are. So you know that jewelry is most often made out of silver, gold, or platinum, and it's because it doesn't react with the oils on our skin, versus other metals would react. So in this lab, we're going to kind of classify which metals are reactive and which ones aren't. So go ahead and make sure you put your name on it because this is a minor grade. The background information is important to read. It talks about the metallic properties of luster, ductility, malleability, and electrical conductivity. And the differences between metals are chosen for different applications, such as that chemical reactivity for jewelry, like we just talked about. Sodium would be a bad choice because just like we saw in one of our demonstrations outside, it explodes in the presence of water. We don't really want to be wearing jewelry that's made out of sodium. You can measure the relative reactivity of two metals by placing a small, pure sample of one metal in a solution containing ions of another. So what that means is we're going to mix metals with a solution of a substance. This is the type of reaction shown. And if nothing happens, then it's like a no reaction. You'll see that right here. So your materials, well, the purpose is to test the reactivity of a variety of metals with different metal ions, then use the results to construct a scale of relative reactivity. So we're basically going to rank these metals as really reactive, somewhat reactive, not reactive. So you need one well plate and 5 pieces of each metal, except for silver. Okay, paper towels to clean up, and you need these solutions. Before we begin, though, let's talk about our pre-lab. How will you be able to tell if a reaction has taken place? If a reaction has taken place, that means a chemical reaction has occurred. This is not the answer. This is help. At the beginning of first semester, we talked about 4 or 5 pieces of evidence that you would see if a chemical reaction has occurred. If you don't remember those, do a quick Google search and then answer question 1. What happens to the ionic compounds in solution? I'm going to help you answer this one. If they're in solution, this means that they dissolved. So the ionic compound dissolves. When it dissolves, it actually breaks apart and you have ions. You'll have a positive and a negative. Which type of reactions are demonstrated in this lab? The lab, this is introducing you to something called a single replacement reaction. Again, this is introduction. I'm not expecting a 100% accuracy on this. I'm expecting you to problem solve through this and think through the process. So if you flip your paper over, it gives you clean cut instructions just like you were cooking in your kitchen, okay? So you need to follow each step. The first one is to clean the well plates with soapy water. Okay, we have these well plates. The problem with these well plates is if you'll notice, this has 1, 2, 3, 4 columns. Ours has that, but ours does not have 4 rows, which is okay because we're not actually doing an unknown metal. Just kidding. We are doing an unknown metal, so you're just going to have to clean it in between. Okay, so you're going to obtain 4 samples of each metal. These are not labeled, so make sure you're paying attention. This metal right here, that's like a powder, is going to be iron, Fe. All right, so we're actually going to have to do some changing on this lab, and that's okay. That's what it is. It's not an unknown. This is actually Fe. Okay. This one right here, that looks like little metal rods. Oh, when did that happen? All right, not really sure when that happened, so let me go back. So this is your iron filing. Okay, so I changed it to Fe. Your copper metal looks like this. That's going to be this first row right here. Your magnesium looks like this. And your zinc looks like this. Okay, so what you need to do is in all 4 of these, you need to put 1 piece of metal. I just put them in the wrong place. Okay, leave your iron filings until the last one. Or you can grab another well plate if they're available and kind of do it that way. Then you're going to pick up your solution that says MgNO3. It's in a beaker. I can't really tilt it too much because it'll spill, but see it says MgNO3. You're going to grab a pipette, and I'm only going to do this first one for you. You're going to pipette it on top of each one of these metals. You're going to move on. You're going to do the zinc. You're going to do the silver. You're going to do the copper. You're going to wait a few minutes, and you're going to see if you see any type of reactions. If you see a reaction, then down here, well, regardless of what you see, down here in your data table, you're going to write your observations. You could write color change to this, the metal is bubbling. You can write all sorts of things. And you need to do that for all of these. If you saw something like bubbling, color change, those are indications that a chemical reaction has occurred. And so you're going to just rank your metals. Which one reacted with the most solutions? Your metals were copper, magnesium, zinc, or iron. And you're going to start listing them in order. And then when you get to question 4, you're going to compare them to the reactivity series on the reference sheets. And the reference sheet is on the back of your pink periodic table, so that's what you're going to use. And then you're going to start kind of walking through these. Now, when it gets to number 5, that one's a little difficult. You can come see me.